Okay, let's give you guys some more practice. So use trigonometric substitution to integrate this. So press pause and have a go. Okay, so to do this, you need to complete the square on this bit here. So completing the square would be, well, because there's a minus here, factor out the minus. So it will give you this, x squared minus 4x minus 5. So now complete the square. So this whole thing here will be the same as this. So now complete the square on this bit here. Completing the square would be you writing in this form here. It would be x minus, and then you're always going to need half of this. So x minus 2, and then squared, and then take away the rubbish. The rubbish being this squared, which would be 4, and then carry the negative 5 over. So that will then give you this. Okay, so now tidy this up. This will then give you this. Well, use whichever method you want. There are lots of ways of doing this. And then tidy this up. This will then give you 9 take away x minus 2 squared. Use whichever method you want to get from here to here. So in order to integrate this, complete the square on this. So completing the square on that will then give you this, and then once you've completed the square, so in order to integrate it, complete the square on this, it will then give you this. So once it's in this form here, create a triangle in such a way that this thing here is true. Create your right angle triangle in such a way that this is true. If you make the hypotenuse, if you make the hypotenuse to be 3, if you make the adjacent to be x minus 2, then the opposite will have no choice but to be this thing here. So create your right angle triangle. So once you get to this form here, create your right angle triangle in such a way that this will be true. Okay, so it will then give you this triangle here. From this triangle, you can then obtain this, because cos theta will be this. Cos theta will be adjacent over hypotenuse. So once you've got your right angle triangle, you can obtain this. So from here, rearrange it to make x a subject. So that will then take you to here. Differentiate both sides. Then this whole thing here will become this, and then this will become dx. So dx equals this thing here. So later on we can put it into the dx here. But we need to replace this complicated thing here. So in order to replace this complicated thing here, look back to your right angle triangle. From the right angle triangle, you can obtain this, because if you look at this here, sine is opposite over hypotenuse. So sine is opposite over hypotenuse. So times both sides by 3, that will then give you this. So this complicated thing here is the same as this. So we can put this into this whole thing here. And then don't forget this dx here, we can put it into here. So this whole thing here will then become this. Okay, so tidy this up, it will then take you to here. Now whenever you want to integrate cos squared or sine squared, you should use something similar to this. Okay, if you want to integrate cos squared, then it would be a plus. If you want to integrate sine squared, it would be a minus. So in order to integrate this, we would substitute this into here. Okay, so from here, that will then take you to here. So once it's in this form here, it's easy to integrate. So integrate it, it will then give you this. Okay, and then tidy this up, it will then give you this. So this here is our answer. But the thing is, we don't want our answer to be in terms of theta. We want it to be in terms of x. So you see, we don't want the answer in terms of theta, but theta here is locked in with this 2. So here you've got 2 theta, but then this 2 theta is locked in with this sine. So we need a way of breaking this up. So to break it up, we would use this. Hang on. So to break this up here, we would use this. So put this into here now. So that will then give you this. So when you look at this here, this is simply sine theta, simply cos theta. Here you've got theta locked in the 2, and then the 2 theta locked within the sine. So use this to break it up into a nice simple sine theta, a nice simple cos theta. Once it's in this form here, once it's in this form here, where you've got one block multiplying with another block, multiplying with this block here, so now this we can easily replace this. So revert back to your diagram. This was our original diagram. If you want to know what sine theta is, sine theta would be this. So sine theta would be opposite over hypotenuse. And then if you want to know what cos theta is, well, cos theta is adjacent over hypotenuse. It's adjacent over hypotenuse. So now, hang on. So you've got one block here multiplying with this. Well, sine theta is this block here. So we can put this into here. And then cos theta is this block here. We can put this block into here. And then now we need to know what theta on its own is. You can either use this one or you can either use this one. Select the simplest of the two, which will be this. So from this, if you want to know what theta is on its own, then inverse both sides. So theta equals arc cosine of x minus 2 over 3. So you can then put this into this thing here. Okay, so this thing here is this. Sine theta is this bit here. Cos theta is this bit here, and theta here is this thing here. Okay, so from here, that will then take you to this. You see, up here, all the answers in terms of theta. Down here, there's no theta. So now tidy the whole thing up, and then it will give you this. So this here is your final answer. Okay.